And the final one is when we're going to react it with ammonia, NH3, okay? So once again, start where there are a lot of electrons. Ammonia has a lone pair of electrons. Bromine's delta negative, carbon is delta positive. So what conditions and reagents? Ammonia, the conditions are going to be heat, okay? It's heated. Right, and by the way, we have two lots of ammonia. You'll see why soon. So always arrows start where there are a lot of electrons and they end where there aren't a lot of electrons. Perfect. Arrows always start where there are a lot of electrons, the bond, and where there's not a lot of electrons. What's this going to do? CH3, carbon bonded to a nitrogen, and it's NH3. So let's fill this in. So we've substituted the bromine, but look, how many hydrogens do we have? 1, 2, 3. Tell me what element nitrogen is in the periodic table. It's in group 5. What is the element? What group is nitrogen in? It is in group 5. Group 5 means nitrogen has 5 electrons on the outer shell, meaning it can only bond 3 times covalently because it has to have 8 out of 8. How many times is it bonded here? 1, 2, 3, 4. So it's going to have 5 plus 4 electrons. 9 electrons. Too many. How can nitrogen lose an electron? It needs to form a positive ion, okay? So it's stable. Now, what did I say we have? We have Br minus here, and we also have excess ammonia. Let's get our other NH3. Arrows always start where there are a lot of electrons and end where there aren't a lot of electrons. Where are there tons of electrons? Here, of course, between these electrons. Let's go to this hydrogen. And where are there not a lot of... sorry. We've drawn the arrow. Now we need to start where there are a lot of electrons and break this bond towards the nitrogen. It's a positive ion, so it's going to have barely any electrons. It's lost electrons. So this is going to make CH3, CNH2, HH. Nitrogen is now happy. It's bonded 3 times. And we've made this molecule here. If you ever want to add these amine functional groups, that's how you do it. You do it by this nucleophilic substitution reaction. Why is it nucleophilic? Nucleophile, positive loving. It loves positive, and electrons go towards the positive species, this time being the carbon.